This is our second video in an example to use the normal model to find probabilities or percentages with normal shaped data. In our last example, there was a statistic that adults can remember about 150 faces, in other words, remembering the face and the name. And we said that there was a standard deviation of 30 faces and a normal model for this data. So let's go ahead and draw what this means. Let's draw our normal model and then we can figure out where we're going to find a probability or a percent. So there's our normal shape. The mean is at 150 people. The standard deviation is 30. And our question now is find the percent of adults that can remember at least 200 faces. So 200 is more than 150, so it'll be over here to the right somewhere. And we want to find the percent, so that means finding area under the curve. I'm trying to find this black shaded area. In the last example, we found area to the left of a cutoff. Now we're finding area to the right. So we have a slightly different procedure to complete this problem. To work by hand, we need to find a z-score. So we need to standardize the number 200. We take 200, subtract 150, and then divide by 30. So this formula was finding your x value, subtracting the mean, dividing by the standard deviation. I just filled in all those places. So filling in what we know, 200 minus 150, so it's 50. Divide that by 30. So we get a z-score of 1.67. So it's really 1.6666 repeating, but rounding out to 2 decimal places because that's how many places we have in our normal table, which is right here next to us. If you're using some other program, you might not even need to worry about this rounding. So I'm going to redraw the normal model because now I've standardized it. I'm now down to a standard normal model. I've done a transformation. So think back to algebra when you did transformations. This is what I've done. 150 shifted to the left, moved to 0. The standard deviation of 30, it shrunk. Now there's a standard deviation of 1. And this 200 is actually now at a z-score of 1.67. We're still finding area to the left. The area hasn't changed. It's just been like shrunk, like a photocopier can do some shrinking, or you can adjust sizes of objects on a computer screen by grabbing the corner, dragging. That's what we've done. We've just shrunk this distribution. So 1.67, that's my z-score. I'm going to go over to the standard normal table right next door, and I need to find 1.67. It's not on the first table because these z-scores are starting with negatives. So I need to go down to the second page of this z-table and find 1.67. So here's my 1.6 row. Here's my 0.07 column. And I know to look for this because of the 1.67. Think of it as like 1.60 plus 0.07 makes 1.67. 1.6 is the row, 0.07 is the column. So where do they intersect? 0.07 column, 1.6 row. Here we go, 9525. Now be careful, that's not quite our answer yet. 0.9525. This is the area to the left because going back to the normal table, it says area under the curve and it's shaded to the left. So I just found this white area to be 0.9525. I need the black area, it's on the right side. I need to subtract from 1. 1 minus 0.9525. This is going to be our answer. 0.0475. Oops, hopefully that's legible. 0.475. This is our answer. It's area on the right side of 1.67. So what percent of adults can remember at least 200 faces? At least, we're going to the right of 200, we get about 4.75%. percent of adults. So that's our answer. Let's use StatCrunch to get this answer now. So I've opened up StatCrunch here. I go to Stat, Calculators, Normal. I have a normal model. And now I'll start filling in what I know. There's a couple different ways to do this. StatCrunch, because you get to fill in the mean and the standard deviation, you can actually fill in the mean of 150, the standard deviation of 30, and then change directions on the sign because we want to find area to the right. See how it just flipped there, the color? We're looking area to the right. Greater than, what was it, 200 faces, and leave the last place blank. This is where we're going to get our answer. Oh, see my error there? My mean is not 15, it's 150. There we go. Make that change. Now compute. Here we go. This is more reasonable. The area shaded there on the right side, it's about the same size as the picture that I drew. And it says that the area is 0.0477935 because it didn't have to do any rounding. We had to do rounding to get to 2 decimal places. Here we have 0.0478, which is close to what we had, 0.75. If we want to compare our answers, let's go back. Well, we can just stop right here. 0.0478 would be an answer. We could turn it in on our homework like this, and we could stop. I just want to compare what would happen if we used 0 and 1, and then our z-score of 1.67. I changed the mean, I changed the standard deviation. Here's the cutoff that I'm interested in. Compute. And here we go. Now we get an answer just like we did working by hand. 0.475 if we round. So just like the table confirms, 1.67 for a cutoff gives us an area of 4.75% in the right tail. So the summary of this is what percent of adults can remember at least 200 faces? About 5% or 4.75 with a little bit of rounding here. Don't try to do anything fancy like round up to 201 faces because we need at least 200. Just use 200 in your z-score. Use the number from the problem.